we're looking to develop a reliable, climate-proof source of water. So we're starting with desalination and making improvements on the conventional method, specifically reducing energy and reducing impacts to the environment.
Our region here of California is not blessed with local groundwater or even surface water that's suitable for drinking. And because of that, we import all of our water from hundreds of miles away. Traditional coastal desalination, it's had a challenge path forward in California. There are a couple projects, but widespread adoption of seawater desalination as a major water supply component for California has not really happened. The reason for that is really threefold. Number one is that conventional seawater desalination is very intensive in its use of energy. So there's a high energy footprint, which then has an impact on contributing to climate change. Also, the intakes where that water is drawn from in the ocean has effects near field to where that intake is, and it affects the aquatic life in the ocean. And then third, there's a brine discharge from the separation of the fresh water from the salty water, and that salty water is returned to the ocean, and that can also have near field impacts to the aquatic life in the ocean. So the technology here that we're looking at, which is called submerged reverse osmosis, really unlocks and addresses all three of those issues. So number one, in terms of energy usage, it uses about 40% less energy than conventional desalination. The reason for that is that we're taking advantage of the hydrostatic pressure of the water because we're placing the unit underwater about 400 meters. So the second thing is the system is designed with what is called a life-safe screen, which means that it has a very unique and proprietary screen system that prevents the entrainment and entrapment of aquatic life, even the smallest aquatic life that's microscopic. Developing new sources of local water is really a critical measure to be more drought and climate ready. And that's what we're doing through this project here.